What's up, guys? And this is part two of the atomic structure and size lecture. So how do we know that subatomic particles exist? Well, there are two experiments that attempted to manipulate matter and that essentially led to improvements of models of the atom. And one of the experiments that I'll talk about is the cathode ray by J.G. Thomson, which is here below. And then the other experiment is the gold foil, which is by Rutherford, 1911, is here below. So we'll go ahead and start talking about them right now. So what's a cathode ray? So a cathode ray is an empty tube. Imagine a glass tube, a vacuumed out tube in which all the matter, the air we talked about, is taken out. And there are opposite charges on each side of this cathode ray tube. When the charge is applied, a stream of particles, this stream of particles is produced. So imagine like having a speaker and getting some power to that speaker, right? You usually use matter like a wire to hook up to the outlet of the wall to your speaker. But there is no matter inside this tube, none. Yet a stream of particles being produced. Well, the stream of particles is also manipulated in a magnetic field. Notice how the bend occurs here. So because this stream of particles can be manipulated, this kind of led to this idea that this stream is actually matter, and this matter must come from these charged plates somehow. So what was so important about this experiment? Well, now the atoms can be proven to be subdivisible into small particles that we can call electrons, charged particles that we can call electrons. So what does the atom now look like? Well, before we start on to talk about that, let's think about this idea. If that matter contains charges, why doesn't the matter then shock you when you touch it? Well, Thomson proposed this plum pudding model. If you don't know anything about plum pudding, think of a blueberry muffin, in which the area of the muffin, right, is a positive area. And the blueberries are these negative electrons that kind of are randomly placed all throughout that blueberry muffin. Well, you don't get shocked because there's positive and there's negative that kind of cancel each other out. So in class, I showed you this video demo of a cathode ray tube. And what I like you to do is I like you to think about these illustrations provided about this cathode ray tube. You know, what does a cathode ray consist of? If the cathode ray bends when it's exposed to a magnetic field, why does it bend? Answer those questions. Think about it. Experiment 2 deals with gold foil. So the question is, what was the gold foil experiment? So the gold foil experiment was this idea using radioactive particles, substances. And I'm not going to go too deeply on what radiation is, just this idea that a rock can push out positive particles and shoot out this positive particle. So Rutherford, aware of this idea of radioactivity, kind of used this notion and constructed an experiment to have these positive particles be shot through a hole, an opening, and through gold foil, right? Or towards gold foil. He lined up a film around this gold foil, which you see here in the letters C, B, and A, around the gold foil. And this gold foil was like a layer with some solution that would light up when the particles would hit the film. When he found out that most of the particles hit really directly behind the gold foil, right? Like as Thomson identified that the atom's probably empty space. But few were really detected at angles and some at really large angles being deflected, right? So what was so important about this experiment? Now think about this, 99.8% of the particles, as I mentioned, went through the gold foil. But yet the large angle deflections accounted for 0.2% of those particles. This means that something is strange about the atom that previously wasn't understood. The atom is not just empty space. There's something that is blocking those few alpha particles. The atoms must contain a charged area that is extremely small and dense, which Rutherford coined the nucleus. In class, I showed you a video of a recreation of the gold foil experiment, right? And I want you to think about these questions from the viewing of the gold foil experiment. What charge do you think that nucleus, that blocked few of those particles, has? How did the gold foil experiment change Thomson's plum pudding model, which you see here below, right, into the new model? So the answer is present here. Here's your nucleus, which is tiny relative to the whole size of that atom. And it contains electrons, still Thomson's idea, that float around within the atom. Since most of the alpha particles go through, that mostly means that the atom is mostly empty space. But yet, since the alpha particles are positive, as they hit that nucleus, they get deflected. And sometimes if it hits right on the money, it will get deflected at really large angles, right? So what's this current accepted theory, atomic theory, right? Well, I brought this up before. The pennies, right? There's about 29 sextillion atoms in a penny. And these atoms look like this in a way. That's kind of the Dalton's idea. But yeah, if we increase this idea behind Dalton, right, expand more, these atoms, which are the tiniest pieces of the atom, are extremely tiny and composed of mostly empty space. If I get one of these atoms and I enlarge it here, this is an atom, and most of it is empty space where electrons reside. This is called the electron cloud, right? The nucleus or the atom also contains mass, as pennies contain mass. But the mass of the atom is actually in this tiny little nucleus that contains protons and neutrons. Protons, which are positive charges, and neutrons that contain no charge, hence the word neutron, right? So really, why are atoms electrically neutral? Why, when you touch an object, it doesn't shock you? Well, really is the amount of electrons, those tiny little particles that float around here, those number of particles are equal to the number of particles present in the nucleus called the protons. And so the number of electrons, say you have 5 electrons, you're also going to get 5 protons. And so that charge cancels out, right? Another interesting thing about the electrons is that they're really tiny. Like if I got a Costco pizza and I divide it up into 1,840 pieces, one Costco pizza would be the size of a proton. One Costco pizza would be the size of a neutron. But yet an electron would be that one piece out of that 1,840 pieces of that Costco pizza, right? So here's some more questions for to check what you understood about the lecture for today. What are 3 subatomic particles in the atom? Where's most of the mass of the atom located? Which subatomic particle accounts for most of the mass of the atom? And then imagine this example. An atom of lithium-7 contains the following subatomic particles: 3 protons, 4 neutrons, and 3 electrons. What's the net charge of the electron cloud? Net meaning the overall charge, right? What's the net charge of the nucleus? And what's the net charge of the atom?